If I were in the same room with you, I would hand you a piece of chalk, and you would see that you cannot write for me what you have just said. And as a chemist, I respond to carbon-carbon, carbon heteroatom bond formations that help me to understand if something can work. And when you speak with such generalities, I cannot process that as a chemist. And I'm trying to be as kind and polite as I can. But it cannot be processed from a chemical standpoint. Every question I posed on the board had no answer. There was no answer. Nobody knows the answer to any of those questions that I posed. That's why I proposed them. And that's why an origin of life researcher, which I'll never again debate a person who is not a real scientist, because it just evolves into nonsense. But no origin of life researcher was there to debate me or will debate me, because I will give them the same questions and there are no answers to them. As soon as you get to the detail, there is no answer to this. But as a scientist, we go to the simplest structure we know, and that's a cell. And your little crystalline environments might couple a couple of things. How those couple of things even got in there is very hard to imagine. And why one pocket has amino acids and the other has nucleotides is very hard to imagine, because the entropy has to be extremely low if each pocket has its own type of material. And as soon as you say, no, well, they can have mixed up materials, then the amino acid hooks to the nucleotide and you're dead. And it's just a chemical complexity which made no sense to me in what you were discussing. Whatever metric you want to apply, I can do what they can do. And I am utterly clueless on how this would come about. And fundamentally, they are too. I have had these private conversations with them, and I say to them, you see the problems exactly what I see. You see exactly what I see. And they don't deny it. They just stare at me in silence. None of us know. If anybody on earth could understand this, I should be among that group. And I can't understand it. Yes, I think their hypotheses are all wrong, and they've been proved wrong over and over and over again. And these folks keep blowing stuff out there that make guys like Dave Farina believe them. And that's why you get all of these people out there believing that life has already been made. Two-thirds of the people, two-thirds of the general population thinks that scientists have already made living cells because of the nonsense that they spew out there.
I think it's just as bad of a problem in cosmology. I don't necessarily want to crack open that can of worms, but I teach astrophysics at a university here, and it's been astounding how we have reified problems into solutions. Like the problem, you referred to these things as dark matter, black this, dark that. They're really just holes in our understanding that we've made into objects that we can slot into our models. And it's sad because the students often think that those are solved problems, even though like, oh, we need to work out the details of dark matter. No, we literally don't understand how 90% of the universe works at a physical level. That's what it really means.
The hydrothermal vents, that's the nursery for life. That's where they begin.
That's one theory. And it's so hard to separate that because there's so much biological stuff under there that comes blowing out, which confounds everything.
Yeah, exactly. So at this point, it's like very difficult metabolism first and energy gradients.
Oh, okay, the metabolism first, yeah. People have tried this. People have tried to take mineral surfaces, and put in lots of sophistication into this. And the amount of coupling that they do with retention of chiral integrity is generally very small. They don't do it cleanly. So every time you try to go in a laboratory and say, okay, I'll follow along that theme. Many people have looked at so-called chiral surfaces, and you don't get the clean chemistry that you're talking about. You just don't get it. What these enzymes do is not just hand and glove orienting molecules in the right space, these very large enhancements in chirality. We have no idea how spins are selected. We don't have a chemistry for that. When you took those two amino acids together, that is, the delta G is positive, which means that reaction does not want to go, which means that now once you have that coupling, it wants to reverse. It wants to go back. And any catalyst it's the principle of microscopic reversibility. It catalyzes both the forward reaction and the reverse reaction over the same pathway. And these all have positive free energy. They don't want to go. And that's going to be the same on in this universe, at any point in time of this universe, that reaction would have a positive delta G. It wants to come apart, doesn't want to polymerize. So you have to have some sort of sophisticated way of driving away the water as soon as the thing coupled so it stays together. And then once you expose it to water to do the next step, it's going to be favoring to hydrolyze this thing. It's a really hard problem, really hard. Same thing with sugars. Every one of those anomeric bonds wants to go back the other way because the entropy goes way, way up. It's very favorable. And that's why delta G is always positive on these things.
What do you make of discoveries of sugars and proteins or polypeptides in interstellar objects?
Yeah. So as far as I know, there are not that many polypeptides. There's certainly amino acids,
Yeah.
and there are certainly sugars. Generally, what we find is that they do not have very high enantiomeric excess. They're generally racemic. There's been a couple of cases where you've seen as much as, say, 65% EE on sugars was the highest that was seen. And it's generally not with the sugars that we know. It's diastereomers of some of the sugars that we're familiar with. And they're mixed in with all the other sugars, so they would be utterly useless. You can make vast mixtures by the foremost reaction, but they're utterly useless even to the chemist today who has these very advanced methods of separating them. Once you have mixtures of sugars, they're very hard to work with because you just get this agglomeration of junk. All right, so you certainly find them. You find amino acids. They're generally racemic. These go through a process where delta G is positive, so the reaction does not want to go. It wants to hydrolyze, go the other way. That's why RNA decomposes so rapidly. That's why the peptides decompose. The sugars, the polypeptides go back to the amino acids, and the sugars want to go back to the monosaccharide, not to the polysaccharide. And the regiochemistry is very hard. How do you get them to hook together where you get a C terminus to the N terminus to the C terminus? Doesn't happen. Any technique that we can think of, thermal, crystal surface, it's all an utter mess. And as soon as you start hooking off those side branches, it doesn't work anymore. It's game over. As soon as one of those, when you polymerize RNA on montmorillon, and when you make RNA from nucleotides on montmorillonite, these clays, you get 30 to 70%, often 70% of the 2,5, not the 3,5 linkage, and you get branching. It's game over. Once you get the branching, it's game over. So that's why as soon as you get somebody on a blackboard, the chemistry doesn't work. We don't know how to make the polymers. And I'm not the first to point this out. The polymers stop everybody. Making the polymerized structures stops everybody. And we've got to make the polymerized forms. Not only is it hard to get the enantiomer compounds, and you want to hook sugar to sugar, if you have amino acids around, amino acids are going to attack that glycosidic site as well. And so you now have amino acid hooked on to a sugar. And so how are you going to make your polysaccharide? You say, well, that's the beginnings of some cell membrane. Yeah, but it's an utter mess. You don't know how to deal with it. So the details of the chemistry make this so hard to fathom that I'm not trying to play coy here. I'm not trying to be the instigator of trouble. I'm just shouting out the obvious to the chemist. The poor man on the street, Dave Farina, the poor man doesn't know. What I learned in that thing is all he could do was read a script. He just doesn't know. But the chemist sees exactly what I see. But they claim something else. Steve Benner, nice guy. We were together a year ago in Israel. And somebody else asked him, okay, if you had all these components, how would you put this together? Could you do this? He says, well, a career is 4 I'm 3.5 score into my career. I'll leave this to other people. And the next day I challenged him on it. I said, Steve, you should have said you can't do it because you can't. Why do you keep saying that? This is why I keep shouting this thing out. These guys keep saying, and Steve has said, we've got this all figured out. We're up to the point right up where Darwinian evolution will take over. This is why, Jim Tours keeps shouting this stuff out. And now I'm person non grata. Lee Cronin is now saying that origin of life is a scam. It's a scam. This is an origin of life researcher saying origin of life research is a scam. And he was asked to explain it on a podcast, and he explained it. He says, because one person makes one molecule after another and after another, and now what? Any cell that has been made, you've taken an existing cell and you put a genome in it, and that goes back to Luca. So he says, nobody's even really doing it, he said. So I say we're clueless. Lee Cronin is now saying it's a scam. Who's kinder?
What life looks like, because the only picture that we have of life right now is cells, and I don't think that's accurate.
Okay, so not everybody would agree with you. Most people would say it comes from cells.
Yeah.
What people are taught all the time. These things came together, and over millions and billions of years, this happened. As a chemist, over a weekend, things turned to garbage. These things hydrolyze, they saponify, they cleave. Time is the enemy of organic compounds. They decompose. And to say that millions of years take care of it is just this is part of the problem. And this is what we're up against. Interactome problem, Leventhal 2.0. The number of combinations of arrangements that you would have that will not work is so utter, 10 to the 70 billion. I mean, this is this crazy, crazy numbers that you could have a billion universes of time and it wouldn't be enough. This is what we're up against. That's why I say we're not going to solve this. And I guarantee you, I'm going to leave this to the next generation and the next and the next, because we cannot get this thing solved.